everybody. So I'll give a talk from Spacetime Causation. Baptiste and Bihan in combination with Meyer. So, there you go.
Thanks a lot. So, all right, folks, great pleasure to be here and to be one of the first talks this morning. So, I have a bit of bad news. I'm going to give the talk, so we won't have a chance and the pleasure to have Sam's lovely accent, and you'll have to endure through my more questionable French accent. Sorry for that. So as you may guess, I'm going to talk about the relationship between time and causation. So let me start with this quote from Bertrand Russell. Can time be derived from causality, or must we retain temporal order as fundamental and distinguish cause and effect as the earlier and later parts in a causal relation? So in a way, Russell is asking, should we go for a temporal theory of causation, explaining causation, reference to temporal relations, or for a causal theory of time, explaining time in terms of causal relations. If we move to relativistic context, it's quite natural to ask this question with the focus on time and on space-time, and ask whether we should go for a spatial temporal theory of causation or the causal theory of space-time. The claim today I'm going to defend is that it's an appealing view that space-time is grounded in a more fundamental causal structure. It's a particular version of the causal theory of space-time, as you will see. And the plan, here's what I'm going to do. I'm first going to introduce you some context and try to give you a sense of the reason why we think it's interesting to think of causal theories of space-time. An idea why we should care at all in the first place because of theories. As you will see, we don't think it's simply a metaphysical curiosity. Then in the second part, I will discuss some issues with identity theories that identify spatial temporal relations to causal relations. And in the third part, I'm going to show how a move from identity theories to other sorts of causal theories of space-time that use grounding instead of identity might help to solve some of those problems. All right, so for the motivations, I'm going to present two motivations. The first motivation is linked to the history of philosophy in the 20th century. So as you probably know, it was quite a popular theory in the 20th century with proponents like Reichenbach, von Frassen, Rundbaum. But in philosophy, things didn't end well for the causal theory of space-time. Anyway, the assault on the causal theory by Jack Smart and John Ehrman was kind of successful, and philosophers lost interest in those causal theories of space-time. But the funny thing is that in physics we observe something a bit different, because in general relativity we have a theorem that philosophers call the Malaman theorem, stating that the metric structure of space-time can be recovered from its causal structure up to a conformal factor. So the idea is that you can rebuild a lot of the information about space-time from information about the causal structure we're dealing with. So it seems there is a discrepancy between philosophy and physics, because either philosophers were too quick in dismissing the view, or those physicists who use this theorem are wasting the time for philosophical reasons. Okay, I won't be talking about that today a lot, but a group of physicists acted on the Malaman theorem. I know you have a research program called Causality theory, where they use this idea to try to rebuild the ontology of space-time from a more fundamental discrete structure. But it's not only that they want to rebuild GR, they want to find a theory of quantum gravity, so they also want to relate the ontology to quantum mechanics. But anyway, let's keep that for later if you're interested. What we think with Sam is that the view, the causal theory of space-time, is worth investigating in more details for those two reasons. And we want to revise the causal theory of space-time in philosophy. And although we think that since those debates were had in the 20th century, philosophy made a lot of progress. We have new tools, Metaphysics toolbox. So it's kind of interesting to try to have a look again at those causal theory of space-time. Yeah, so as I mentioned, causality theory is a particular approach to quantum gravity. And the second motivation is that according to a number of those approaches to quantum gravity, space-time is not fundamental or doesn't exist. There is a lot of discussion about what it means exactly to explain that space-time emerges from something else. And it's kind of open to debate how to make sense in ontological categories of this situation, right? To understand what could be happening according to those physical theories. And so that's the second motivation. Pam and I believe that the causal theory of space-time could help. It could help us to make sense in ontological categories of what it could mean that space-time emerges. And the idea would be that you may have a fundamental ontology made of causal relations, and described by your theory of quantum gravity. This causal structure will be non-spatial temporal and will somehow give rise to space-time. Right. Okay, so there's the two motivations to have a look at causal theories of space-time. So we don't think it's just a metaphysical curiosity, we think it's promising to have a look at that. So now I'm going to present very briefly the identity theory. And here again we think it's important to keep in mind to have a space of different views on the table. Right, so the first distinction is between identity theory versus non-identity theories, right? And the two classes of theories differs in their answer to the following question: are spatial-temporal relations identical to causal relations? And here note that we focus on relations, so the relata of the identity relations are themselves relations, causal relations, space-time relations. Right? So we ask what's the relation between those relations? Is it identity or not? So we're not focusing here on the whole space-time or on regions. Right. So the idea of the identity behind the identity theory, which is a particular sort of causal theory of space-time, is that any spatial-temporal relation is also causal connection. Then we can again distinguish between two versions of the identity theory. One is stronger than the other. I'm going to present them now. So this person here is Jack Smart. I'm going to put a quote of him in a minute. So the strong identity theory seeks to define spatial-temporal relations as causal relations. Right? So the idea here is to move to have a conceptual analysis of the relativistic space-time in causal terms. Right? So here the important word is defined, but of definition. Of course, it's a strong theory, and there are several problems with this approach. The first problem is the following that Jack Smart mentions: to elucidate the concept of space-time in terms of the concept of causal connectedness seems to be to elucidate the comparatively clear by reference to the comparatively unclear. Right? The idea will be space-time, we have a clear understanding of space-time. Causation is more mysterious, so why try to explain something which is clearer with the help of something that is more obscure? So, well, one thing we can say that nowadays, given that our understanding of causation has progressed a great deal, well, Smart's worry has perhaps less light. Right? Now we have more formal theories of causation, for instance, with interventionist framework. There is a lot of work. But it's not completely toothless, we think, as we have a mathematically precise understanding of space-time, right, in geometric terms, and we have nothing like that for causation. So that's something to think about. The second problem for this strong identity theory, the conceptual identity theory, is that it's entirely conceivable that there could be a world in which relativistic spacetime exists, but that is completely free of any causal relations, and vice versa. Think, for instance, of a spacetime world that is causally idle, in which nothing ever happens. Or conversely, we can imagine worlds with causation that do not feature relativistic spacetime, where space and time are different manifolds, as in Newtonian worlds. You can imagine all of that. So fair enough, you could say, well, perhaps these worlds are just physically impossible or even metaphysically impossible, but nonetheless they seem to be at least coherent. They are not conceptually incoherent. So that's another problem for an identity theory that will be ambitious in trying to have a form of conceptual analysis. So one obvious move is to retreat to a weaker identity theory that doesn't require to define spatial temporal relations in terms of causal ones. Right? You can think of the famous example, discussed very quickly. Just as the concept of water and H2O can differ radically, so too for the concept of space-time causation. Right? So it would be a non-transparent identity, empirical identity. Thus, the weak identity theory seems to avoid the broadly conceptual problem we just saw, and has some claim to being the standard form of the view within philosophy. And since one is not seeking any kind of conceptual analysis, it also doesn't matter whether causal relations are less well understood than spatial temporal ones. The identification may still be apt and useful. Right. But now here, we think there is still a strong substantive problem for the identity series, for the weak identity series. And to start with, let's have a look at this other quote from Smart. It's difficult to see how the causal theory of time is applicable to theories which allow for the existence of events which are neither causes nor effects of other events. So the problem is as follows: any spatial temporal relation must be a causal connection, which means that there cannot be any entities that are not causally idle so long as they bear spatial temporal relations to other entities. So the weak identity series applies incorrectly to Smart that everything does and must do something. Right. So in fact, we think this problem of causal indolence is really a cluster of three different cases, three different situations, and the three worries are based on three different situations. One is the case of empty space-time regions. The second interesting thing to discuss is a case of time-like but not causally connected events. And the third case is a case of space-like but not causally connected events. So here I'm just going to assume that you have a sense of distinction between time-like and space-like relations. If that's not the case, I'm happy to talk about it later. So first, empty space-time regions. Well, here the worry is that there might be regions space-time that are completely free of matter and energy, and thus of causation. Now here is a possible answer we may have. Well, it's unclear that all fields can have zero value anywhere in the actual world. Think, for instance, of the remnant light of the Big Bang. It permeates the universe everywhere, and this radiation is an oscillation of the electromagnetic field. Force field carrying energy. Usually physicists don't think of it as a matter field, but rather a force field. But still it carries energy, so it seems to be something. So at least this field is not zero valued anywhere. So there might be a strategy here to answer the worry of empty space-time regions by just denying that there are actually space-time regions that are empty in the actual world. That will be one way to go. Okay, second version of the causal, of the problem of indolence, of causal indolence, the case of time-like but not causally connected events. Well, many pairs of events are time-like separated. One can be represented as located in the past or future light cone of the other. And among those pairs, only some of them seem to be causally connected, at least in kind of usual understanding of causation. Think, for instance, about you raising your hand right now, and the burst of a supernova in galaxy Andromeda in the far distant future. Those two events do not seem to be causally connected in the ordinary sense of causation. However, they are timeline separated. Right? So we think we have a lot of timeline relations that don't seem to be also causal as they should be according to a normal theory of space. Right. So, yes, so let's say it's unclear the situations in which, sorry, that's a new bit. We could use the same strategy as with spacetime, empty regions of spacetime, and say, well, it's not that clear that situations of this kind really happened. Are we really sure that there is no causal connection between you raising your hand and the burst of the Andromeda galaxy? Well, maybe there is a sense in which the event in Andromeda could be affected in a negligible way by the modification of the field caused by you raising your hand. So that might be one way to try to neutralize this worry. Alright, so one could think those differences, those relations make, however tiny, are still causal in nature, and it's maybe all we need for the causal theory of spacetime, for the weak identity theory. So let's agree maybe we can address this worry. Still, there will be a stronger worry related to space-like but not causally connected events. So, in general relativity, by definition, space-like separated events cannot be causally connected. Right? So that's the way they are defined. Hence, those events are spatio-temporally related, but they cannot, as a matter of principle, be related by a physical signal of any kind. And this is taken to also imply that they cannot be causally connected. This version of the worry seems to be untouched by the considerations reduced thus far. So it seems it's a stronger challenge for causal theory of spacetime. How are we going to deal with the space-like relations? So we think this causal inverse problem, at least this version, even if you manage to satisfy the two other versions of the problem, it motivates a shift away from a version of the causal theory of spacetime based on identity. So that's our motivation for trying to develop another sort of causal theory of spacetime. All right. So moving to non-identity theories, and by this we mean theories using grounding, for the specialists of grounding in the room, we have in mind small g, grounding, quite liberal notion, but one that excludes identity. The idea here is that not all spacetime relations are identical to causal relations, but they must all be grounded in causal relations. That's the way to think of the matter. Another task, of course, thinking about the problem of causal equivalence, is to find causal relations that ground space-like relations and explain how they can do that. So we think grounding is interesting for the task because it's more liberal than identity in several ways. So one is that unlike identity, grounding allows for a relation at one level to be grounded in the absence of a relation at another level. So to take a very simple example, so that's from Sam. Suppose that there is a private club with the following membership condition. Someone can only be a member of the club if they are not biologically related to anyone already in the club. In this situation, the membership condition, the membership relation between two members of the club holds at least in part, in virtue of the absence of any underlying biological relationship between them. So you can see the in virtue of that proceed for relation of grounding. That's an example of how an absence of something in a particular ontology can ground something else. Another way in which grounding is more flexible than identity concerns the size or the extension of the grounds compared to the grounded. Grounding allows that what underlies a relation might be more than just a single relation. Right? What grounds a relation might be a great many relations or a complex system of facts. Take another example, the relation of citizenship that many people stand in toward a country. Well, I think this relation holds when it does because of an entire complex of facts concerning the individual and the country at issue. There is no single factor that grounds citizenship. Right? So in a way, one way to think of it is that the grounding relation is many to one. And if you think that identity is one-to-one, that's another difference that may be interesting to solve the problem that we're trying to solve here. Right. So with this in mind, here is a non-identity theory defined now. The proposal is to use those two dimensions of grounding to define the non-identity theory. And the idea is that spatial temporal relations between time-like separated events are grounded in the presence of causal relations between events. Thus, if two physical events are linked by a fundamental causal relation, then that's sufficient for them to be time-like connected as well. And now what's very interesting is when we move to those problematic space-like relations, the idea that relations between space-like separated events, in contrast, are grounded in the absence of causal relations between events. Right, so here is a way to represent this. So you can think of what you see on the left as a future icon. Right? This will be the time-like relation between two events. This will be a space-like relation between two events. And when you move on the right, you try to have an ontology of causal relations and to make sense of this collection of entities grounding this. So the idea would be that the presence of a causal relation between those two relata ground the time-like relation between those two relata. And here is the absence of causal relation between those two relata grounds space-like relation. There are many details I'm going to talk about. Happy to discuss it during the Q&A. But we think we can do more than just ground the distinction between space-like and time-like direction. We also think that if we plug enough structure here, with a theory like causal set theory, you can make sense also of distances, of space-like distances and time-like distances in terms of the number of causal relations involved here. All right. I'm going to conclude. So we have elaborated a model based on the simple idea that causal relations could be more fundamental than spatial temporal relations instead of being identical to them. We take this non-identity model to solve the causal intolerance problem. The model could also help to explain the evolution of space-time and quantum gravity, and for us that's really an important motivation. That's really what we are after in the end. We think that future work could be profitably directed at identifying new causal properties of space-time, assessing the merits and comparing them with the non-identity theory presented today. Not that we did this, but we think there is a lot of discussion to be had. There are many ways to go. So our main objective is really to convince you that there's more work to be done, and we should really try to investigate this in more details with some eyes in the physics of quantum gravity. So we think the causal theory of space-time remains a promising view, and one that deserves to be put back on the agenda within philosophy. So before I stop, I have a few more minutes. 2 minutes?
About 3 minutes.
3 minutes? Okay.
We started a little bit.
Yeah, yeah, okay. So I have a few more slides. So just first thing, so we have this in the forthcoming paper in Moose. And if you are interested by the project, yeah, come on, welcome, have a look. And the big part from the paper I removed is a presentation of causal set theory and how to plug this into the metaphysics. So that might be interesting. Also, I will take the opportunity, since I have a bit more time, to say more about what we mean by causation. You might wonder, what is causation in the first place? What are your what do you need causation to be for the theory to works? So I'm mainly consider the literature, of course. And our strategy is to be as neutral as we can, in a way. But we cannot be completely neutral, right? So we still need to accept a kind of minimal realism and defend that there are modal connections in the world that can be probed with the interventionist framework. So we use also in the paper the interventionist framework to argue that the relations found in causal set theory are causal. But it doesn't mean that we think that it has to be the end of the story, or that we must think of interventionism as the right way to think of causation. We think it might be coupled to more fine-grained theories of causation. So we'll probably pick the one who favors the most, the metaphysics of causation literature. Yeah, probably I'm just going to stop. Thank you very much.
Can I plug you? I have to be plugged for. Okay.
All right, turn it over to Ulrich. Let's get some comments.
Thank you. Very much. Can I use this?
Yes.
Oh, wow. No. That's not gonna. Okay, thank you very much. After a paper with French accent, now we're going to get comments with a German accent. See, poorly pronounced English is the lingua franca of the modern world. That's the fun of that. Okay, so I want to keep this quick because I know nobody is really interested in a commentator. People just want to ask their own questions. But this, in some focus in the paper, focus on the causal and spatial temporal relations and argue that the latter ground the former. I want to ask a question about the relata of these relations, relata of causal relations and relata of spatial temporal relations. Let me remind you of the orthodoxy on this matter. The orthodoxy is that causation is a relation on events. That didn't really become fully clear in the philosophical literature until after everybody had abandoned causal theory of time, causal theories of space-time. That's the work of Donald Davidson, and then later David Lewis in his account of both events and causation. But even before, right at the birth of space-time theory, it was always events that are the primary occupants of space-time. So you get that both in Einstein and Minkowski, where first they start by talking about space, which is occupied by objects, and then they talk to space-time, and all of a sudden, the primary occupants of space-time are events. Then we go from Körper to Ereignisse without any explanation of why we're making this transition and what these events might be. So events are the primary occupants of space-time. Those are the relata of causal relations. which initially looked quite promising because then in that case the two sorts of events, two sorts of relations that we're comparing at least are on the same relata. The problem I want to draw attention to is that, at least on the orthodox view, events are not fundamental entities. They're not part of the fundamental furniture of the universe, but they're usually cooked up out of something else, and one of the ingredients out of which people cook up events is either space-time or time. So they're made up of space-time plus some other stuff. So here are three popular views. Quine wants to identify events with the contents of spatial-temporal regions. Lewis has a more fine-grained account. For him, events are properties of spatial-temporal regions, where properties are spelled on in this modal realist manner. Jaron Kim, for him, events are triples of a substance, an accident, or a property, and the time. And you see, the reason we need to have the times in here is, amongst other things, is that we want to distinguish qualitatively indistinguishable events that really happen at different times. So that's the orthodox view. Events are made up out of these spatial temporal entities. So here's my question for Baptiste and Sam. So the orthodoxy is that space-time is more fundamental than events. If we are to have a causal theory of space-time, which that's a theory that's going to invert the order, rather than having a start out with space-time, make up events, and then...
Welcome everybody. So about to hear a talk, grounded space-time causation, by Baptiste and Bihan, in combination with Meyer. So, there you go.
Thanks a lot. So, all right, folks, great pleasure to be here and to be one of the first talks this morning. So, a bit of bad news. I'm going to give the talk, so we won't have a chance and the pleasure to have Sam's lovely accent, and we'll have to endure through my more questionable French accent. Sorry for that. So as you may guess, I'm going to talk about the relationship between time and causation. So let me start with this quote from Bertrand Russell. Can time be derived from causality, or must we retain temporal order as fundamental and distinguish cause and effect as the earlier and later parts in a causal relation? So in a way, Russell is asking, should we go for a temporal theory of causation, explaining causation, reference to temporal relations, or for a causal theory of time, explaining time in terms of causal relations. If we move to relativistic context, it's quite natural to ask this question with the focus on time and on space-time, and ask whether we should go for a spatial temporal theory of causation or the causal theory of space-time. The claim today I'm going to defend is that it's an appealing view that space-time is grounded in a more fundamental causal structure. It's a particular version of the causal theory of space-time, as you will see. And the plan, here's what I'm going to do. I'm first going to introduce you some context and try to give you a sense of the reason why we think it's interesting to think of just causal theories of space-time. An idea why we should care at all in the first place about the theories. As you will see, we don't think it's simply a metaphysical curiosity. Then in the second part, I will discuss some issues with identity theories that identify spatial temporal relations to causal relations. And in the third part, I'm going to show how a move from identity theories to other sorts of causal theories of space-time that use grounding instead of identity might help to solve some of those problems. All right, so for the motivations, I'm going to present two motivations. The first motivation is linked to the history of philosophy in the 20th century. So as you probably know, it was quite a popular theory in the 20th century with proponents like Weichenbach, von Frassen, Woodbaum. But in philosophy, things didn't end well for the causal theory of space-time. Anyway, the assault on the causal theory by Jack Smart and John Ehrman was kind of successful. and philosophers lost interest in those causal theories of spacetime. But the funny thing is that in physics we observe something a bit different, because in general relativity we have a theorem that philosophers call the Meyer theorem, stating that the metric structure of spacetime can be recovered from its causal structure up to a conformal factor. So the idea is that you can rebuild a lot of the information about spacetime from information about the causal structure we are dealing with. So it seems there is a discrepancy between philosophy and physics, because either philosophers were too quick in dismissing the view, or those physicists who use this theorem are wasting the time for philosophical reasons. Okay, I won't be talking about that today a lot, but a group of physicists acted on the Meyer theorem. I know you have a research program called Causality theory, where they use this idea to try to rebuild the ontology of spacetime from a more fundamental discrete structure. But it's not only that they want to rebuild GR, they want to find a theory of quantum gravity, so they also want to relate the ontology to quantum mechanics. But anyway, let's keep that for later if you're interested. What we think with Sam is that the view, the causal theory of spacetime, is worth investigating in more details for those two reasons, and we want to revive the causal theory of spacetime in philosophy. And also we think that since those debates were had in the 20th century, philosophy made a lot of progress. We have new tools, metaphysics toolbox. So it's kind of interesting to try to have a look again at those causal theory of spacetime. Yeah, so as I mentioned, causality theory is a particular approach to quantum gravity. And the second motivation is that according to a number of those approaches to quantum gravity, space-time is not fundamental or doesn't exist. There is a lot of discussion about what it means exactly to this claim that space-time emerges from something else. And it's kind of open to debate how to make sense in ontological categories of this situation, right? To understand what could be happening according to those physical theories. And so that's the second motivation. Pam and I believe that the causal theory of space-time could help. It could help us to make sense in ontological categories of what it could mean that space-time emerges. And the idea would be that you may have a fundamental ontology made of causal relations, as described by your theory of quantum gravity.
Like kind of epistemic worry, they seem to first check that these things could be possibly connected by checking if they are time-like connected, and then can establish if there is some causal relationship. I don't know if this is a worry or not, but the way they figure out these things in part is first to look at the time-like structure, and then check interventions, like, oh, the effect of this, does this change it?
Yeah, I'm not sure. I mean, so is your worry that this kind of, because what you are pointing out are more a matter of methodology and epistemology. So how would this bear on the metaphysics, right? Because it might be that causal relations are more fundamental than time-like relations, metaphysically speaking, even though methodology we have to do this kind of checks the other direction. Or so, yeah.
We can talk more about it, but I think the worry is that maybe necessary condition is the other way around. But I'm not completely sure. I have to think more about it.
So, and here first, thank you.
Yeah, thanks. I wanted to ask about the claim that a lack of a causal connection grounds a space-like connection. I was thinking there might be some views in tension with that. So suppose you're David Lewis and you believe in island universes. Take two space-time points in different mosaics, no causal connection, but no space-like connection. Or also, I mean, if you believe in abstract entities, they might not have causal connections between them, but they're not space-like connected. So yeah, I wonder if you have responses to those kinds of examples.
No, that's absolutely right. Okay. I've put a slide on this because I had a longer version of the talk where I was addressing this point, but I decided, okay, I'm just going to remove it. So hopefully someone will ask this question. Yeah, so there are many cases where...
You need to wiggle the desktop, please, because I think that's the thing that's asleep.
Which one?
I was just wondering if the connection to the desktop is what.
I mean, it's okay. So you can have the condition of the absence of causal relations seems to be too strong because we can find many examples where it seems we don't have causal connections, and we don't want to say that the relators of relations are space-like separated. We can also think of, I don't know, like the absence of causal relation between two abstract entities. We want to say that the abstract entities are space-like separated? No. So we need more constraints. So the way we did that in the paper is to have some rules. So we add some rules on top of the ontology. And so you have things that are possible, things that are not possible. And so we have a stronger condition, which is that according to the law, the rule, it will not be possible for the two things to be causally connected. The idea that those laws on the causal structure determine the modal status of absences and presence. So in a way, we're kind of cheating to hide this part because there is some cost in having those rules. But in the paper, we add this content explicitly and say we need that to address the kind of issues you just mentioned. I guess it's one way to go.
Yeah, okay. So I wanted to go back to about the last sentence you said in the regular talk about distances, because the space-time is a metric. So space-like time-like are not just qualitative categories. If it's something space-like separated, it's separated by a certain distance, right? And that has concrete. That is not just a term that you can, for example, say when will there be an influence from this event on the light in which I am. So I don't quite see how you can reconstruct that sort of measure on your theory, because it kind of, I'm trying to imagine sort of the absence of all sorts of, I start to do like lots of absences just to sort of constrain where that point really is in space, and then I'm kind of back constructing a space-time in other terms, so that doesn't seem to be very straightforward. So I think the metricness of things is a little bit problematic here.
Yeah. So the way we did it in the paper was in a particular context of causal set theory. So we help ourselves with an ontology of a discrete ontology. So it's basically an ontology of relations of partial order between relator. And there are some rules on how the elements, the CST elements are connected. And you can straightforwardly think of the time-lag relations as corresponding to the number of relations on your point A and point B, let's say. So you count them, it gives you an idea, a notion of the metric along a time-lag direction in the GR description. And the trick for the space-like relations is to look at this kind of a tree structure. So you look at the number, the minimal. So you have points, let's say you have points A and B in the causal structure. You have no direct connection between them, but you have ancestors.
Right.
So you can count the number of tokens of relations of partial order between those 2 points is the closest common ancestor. And the idea would be that this might give you an ersatz of space aggregation, or give you a sense of the space-like. Basically, the space-like distance will be grounded in the minimal number you need between those two relata to get to the closest ancestor of the CST equation. Okay. Yeah, so sorry I don't have the for you, let's say.
Just to get the key here, we have here, you, and then here.
Yeah, thanks for the talk. This is really interesting. So I have a quick question. So we got to get the proposal if we assume something like relativistic space-time with relativistic dynamics. So I'm curious as to what you think about other prima facie possibilities. So let's even keep, say, relativistic space-time, but take a world without relativistic dynamics. So let's say
Is that sorry?
without relativistic dynamics, or whatever. Let's say it's a Newtonian world. Let's say the only law isn't a holistic law, like blue and red things can't be within 3 feet of each other. That's it. No dynamical laws that things move around or whatever. If that's our picture, then it looks like we have a world of space-time. It's not clear we have causal relations or characterization of causal relations that's going to allow us to go backwards and characterize the space-time in terms of causal relations. You need a kind of proposal that lay out here. So do you just so what do you think about possibilities like that?
Well, of course, there is a question about what are those sorts of possibilities? Are they just conceptual possibilities, physical possibilities, metaphysical possibilities? I guess personally I'm more interested in trying to find a causal theory of space and that works for the actual world. So if your objection is that it would not work for those kind of worlds, it's a cost. I consider it's a cost. But I guess I would not be worried if it does work for the actual world, and you have to accept that those conceptual possibilities are not really metaphysical possibilities. That will be my gut reaction.
Okay, so thank you for the great talk. So I have a question about the relation between causality and grounding, because it's not completely clear to me exactly what picture of grounding you have in mind. I mean, in the literature, generally speaking, we know that the grounding is a well-founded partial order. Then we can discuss whether or not it is irreflexive or whatever. But grounding entertains, relation with modality, supervenience, and also causality. And as far as I know, you can defend the idea that they're exactly the same grounding, exactly the same as causality, they're completely disjoint, or that they share some common aspects that the position held by, for example, Schaffer, defending the idea that causality acts at the same level, whether on the opposite side, grounding cross-cuts among different levels of causality, so of reality, sorry. So my question is, are you defending or are you taking for granted some particular view of grounding or the relation between grounding and causality?
So we are taking the notion of small g grounding. So it's almost like a placeholder for many possible relations. For instance, for me, I really like to think of the kind of grounding involved here as being composition, a kind of non-standard form of composition. And I say we assume that it's not a relation of identity. Right? That's what we assume. Then for the other questions, I don't think we are assuming a lot, because the literature on grounding is quite massive. A lot of disagreement on those properties. So basically, I just said what we need for it to work. We needed to rule out identity, and then we want it to be. It's almost just that it's a notion that rule out identity that can be many-to-one and can help you to ground things in absences. Then for the rest, I think it's kind of open. I don't know. Do you think there is more to be said about the formal properties here?
The only thing I'd say is that we're not assuming the Schaffer picture of grounding, which is this primitive relation that you wheel out that's independent from causation, composition, and these other things. So it's sort of not in that zone at all. It's more like, look, there's grounding. It could be like composition, constitution, all these other types of relations. Plug in what you need, build your model from there. We don't need this Schaffer notion because it scares me.
It's extremely flexible.
Yeah.
Okay.
Thank you.
Yeah, thank you. So I think I just want to comment a little bit on that causal set theory stuff. I think you're right that your view goes well with causal set theory view, but I'm not quite sure that that is as much of an advantage as it might look at first, because I think a large part of the causal set theory picture strikes me as underdeveloped. On the one hand, there's like the metaphysical stuff, the worry about events, and the relative causal relations that I raised. But even as a physical theory, I mean, it's at best prolegomena to any future of physics that might come forward as a science. Right? There's a lot of physics that we don't get in the causal set theory picture. And the second question about, just think about the metric field question, or any other field, which in a covariant formulation of a physical field, we have this like four-dimensional space-time manifold, and then we have the metric field and the electromagnetic field, and they all live on this spatial-temporal manifold. And one reason for being space-time substantivalist is precisely that. You need some sort of medium for free fields to live on, and space-time points are just the right thing to do that. So in any ordinary formulation of modern physical theories, space-time is doing all that work that it isn't doing in the causal set theory picture. So my worry, I guess, is a little bit like the first two questions. How is that going to filter down to an ordinary physical theory where it's hard to see how you could not take space-time seriously as some sort of fundamental entity?
Right, okay. I mean, if you look, what you talked about ordinary physical theories, right? But it depends a bit on what you mean by this class of ordinary physical theories, right? If you take seriously the issues of consistency and explanatory power between quantum mechanics and general relativity, and I think we need a more fundamental theory of quantum gravity, then you can look at all those classes of research programs or attempts at building a theory of quantum gravity. You might have all of them not really well-behaved physical theories. I think if you read things that anyway, we get clues from GR, we get clues from quantum mechanics. One other thing also about the clues we get from those research programs that try to unify them. And I would say, well, causal set theory is not alone in its rejection of the fundamental space-time. String theory, loop quantum gravity, they all make claims towards the fact that space-time is not fundamental. If you take string theory, for instance, I mean, it seems that things are defined against relativistic space-time, so you might think that we still have space-time there, but you have those relations of duality between different string theories that are perturbative theories that seems to entail the existence of different ontologies. So one way very quickly to read the situation is that you cannot trust any string theory to give you access to the ontology of the world. So the best thing we can get from string theory are constraints on how the ontology could be, for explaining why those perturbative theories go the way they do. And those kinds of constraints we get point in the direction of the fact that space-time is not fundamental. Because it's almost like there's a duality between theories defined on different space-times. So if you have a popular common core approach to string theory, we think that what's real, what's in the ontology, what's common to all the models of the superstring theories, and then you will not find space-time, right? So my answer to you is, fair enough, space-time seems to be everywhere, and we use metaphysics of GR and quantum mechanics. When you move to the metaphysics of quantum gravity, we get a lot of alarming signals that something will have to go.
So we say, yeah, we move to metaphysics. My one is just look at physics. We've done no experiments in any of this stuff. We've had this problem of GR and quantum mechanics for 100 years. And all we've done since then, we waved our hands, we have these little toy models. And we had string theory, and this, that, and the other. Well, we don't have any experiments. So, yeah, I can see some exciting metaphysics in the offing, but so far we don't have any physics. It's all theorists sitting around in a room talking to philosophers, making up some stuff. The experiments at CERN that people do, they just do with physical theories they can test. They don't do with causal set theory models. And that's kind of a little bit of worry about it. When when I say SMS a prolegomena in future physics, is that a physical theory is one that you can actually test in in none of these grand unified theories we've ever done any.
So are you suggesting to discontinue the field of theoretical physics?
Sorry, I want to get to these last two questions since they have their hands up for a while.
Thank you for the talk. I was wondering if this, sort of following up on one of the earlier questions, this like the closest ancestor, or sort of the intersection of the light cones, if sort of a straightforward version of that is going to be sufficient, or if we're going to have to like chain them. So I'm thinking with like inflationary cosmologies, you can have things that are really, really far spatially separated, and their light cones will never intersect. And there are certain models where they're also not going to connect to the map. And so I'm wondering if you're going to have to say something like, well, they're causally connected to something that's causally connected to something that's causally connected to the event that we're interested in. And if that's fine, or
yeah, we say it's fine.
All right.
Easy. If I got it right with that, I may have raised this question, but I think it's fine. Yeah.
Okay. Yeah, so my question is weird in the sense, but so far your narrative has been a lot of sort of possibilities. So here's an objection. Well, here are things which, if they were true, they would deal with the objection. And the causal theory, you said I'm kind of open-minded as to what theory of causation we have. It just needs to be a theory which possibly could do the work. And similar with the objection, that you said, well, here's one way to go, and here's another way. So it sounds almost as if you're saying it's logically conceivable that there could be a view in which spacetime reduces to the causal theory. But sure, but to buy into it being true, wouldn't that require a very strong view on what this beautiful theory of causation is? And so why would you personally buy into it without having such a theory?
So can you just repeat the last two sentences?
So you didn't really give us an account of a very strong view on causation and what it is. Mm-hmm. And so why personally do you still think it's a good view without, in the absence of a strong view on causation?
I mean, it's still quite kind of metaphysically strong in the sense that you accept primitive tokens of causal relations in your ontology, right? So you must accept the fundamental level of reality you have causal relations. And the reason to do that is, I mean, it's in a way, it's kind of an empirical approach to metaphysics. So it's messy because the idea is to try to build metaphysical understanding that there's a lot of jobs that explain some facts that are very difficult to explain. Because you might say, well, causal theories of space-time, it's a bad idea because for the kind of arguments Mel mentioned, that one is space-time is clearer, so why it goes that direction. But as I mentioned, we also have this other motivation coming from interpreting the physics of quantum gravity, if you take it seriously. We need to make sense of something that is very difficult to make sense of. And the idea is that those causal theories of space-time provide a way of doing this. Right? So it's on that term. It's not, our proposal is not made to say that causal theories of space-time are correct, are true of the actual world. The attempt is more to say there is a promising way to make progress with this very difficult problem of space emergence. But
I guess as much of that is wasn't in the talk, I guess, right? It requires a background knowledge of what these causal theories are doing.
All right, with that, thank the speaker. About 3-minute break.